Hello and welcome to Easy Maths. In today's lesson, we're going to look at the second objective, solution of linear inequalities. And this forms one of our lessons in a series of lessons on the topic of linear programming. So let's go straight to that part, solution of linear inequalities. And we're going to tackle the concepts in this lesson by just looking at questions. I'm going to focus on 3 questions, and so this first video has 2 of those. And so let's begin with the first one. We thought a headmaster intends to spend not more than 8,000 shillings in transporting 70 students to a football match using 2 matatus, A and B. So these are 2 types of matatus. A has a passenger capacity of 10 and B a capacity of 28. The cost per trip for A is 1,200 shillings and for B is 2,000. If A makes less than 5 trips, find all possible solutions for the number of trips made by each matatu. As we begin this question, I'm going to say these 2 statements. 1. Let X be the number of trips made by A. That means X is the number of trips. It's a count, 2, 3, 4, something like that. And again, Y is the number of trips made by Y. Having thus said, if we consider first of all the number of trips made by A, we should notice that we are told if A makes less than 5 trips, that already implies an inequality, which means X, which is the number of trips made by A, is less than 5. And that implies an equation X is equal to 5, which we will draw later on. We move on to cost of trips. Cost of all the trips. We have been told that the headmaster intends to spend not more than 8,000 shillings, and that means since X times 100 would be the total cost that goes into transporting the students using type A, and Y times 2,000 is the total cost of shillings used to transport students using type B, then that amount should not be more than 8,000 shillings, probably the amount the headmaster has to spend. X is the number of trips, and 1,200 is the cost per trip. So this is the total cost that goes into transporting using type A, and Y is the number of trips made by type B. 2,000 is the cost per that trip, so Y times 2,000 is the total cost that goes into transporting students using type B. And therefore, the total cost of those should not be more than the amount that the person has, and therefore it's less than or equal to 8,000. That should simplify to 1,200x plus 2,000y is less than or equal to 800, which you can simplify further to get 3x plus 5y is less than or equal to 20. And that gives us the equation 3x plus 5y is equal to 20. Now if you set x is equal to 0, you're going to get y is 4, and if you set x is equal to 5, you're going to get y is 1. It's always important to set x and y to be whole numbers, or ensure that you get whole numbers for x and y here so that they are easier to plot. We move on. The number of trips made by both matatus. We've been told that this person is transporting 70 students, so we should have an inequality like this: x times 10 plus y times 28 is greater than or equal to 70. The reason is x is the number of trips made by A, whose capacity is 10. If you added that with y times 28, where y is the number of trips made by B, whose capacity is 28, it should be equal to the number of students we are transporting, or more than that. It should not be less than that, because if it's less than that, it means that some of the students will not be transported, and yet maybe these students are going to participate in a match or something, so they should all of them be transported. We'd rather have a car or one of the matatus having unoccupied seats than the opposite, where some students would not be transported, and therefore this is the way the inequality should be: greater than or equal to. And this should simplify to 10x plus 28y is greater than or equal to 70, which again simplifies to 5x plus 14y is greater than or equal to 35. And that implies an equation 5x plus 14y is equal to 35. And if you set x to be 7, y will be 0. And if you set x to be negative 7, y will be 5. Again, you have 2 inequalities: x is greater than 0 and y is greater than 0. And those 2 implies these 2 equations, which are the x and y axis. I should say that the reason we are setting, or we are putting these 2 it's because we're assuming that A will make some number of trips and also B should make some number of trips. In other words, we cannot say that we are not going to use type A at all or type B at all. So the numbers there should be bigger than 0 for both x and y, giving us these two equations of lines. And again, we're going to use those ones to plot on the Cartesian plane. And so at this point, we draw. Before us is the Cartesian plane, and the axes are labeled. X is equals to 0. We have 3x plus 5, y is equals to 20, x is equals to 5, and 5x plus 14y is equals to 35, and this y is equals to 0 here. Now, as we move forward, we need to know how to shade these ones. And so let's begin with the first one. 3x plus 5y is less than or equal to 20. This line here. As we want to shade that, we're going to do it this particular way. 1. Let's take a point O, that is 0, 0. This is the origin, this point here. We know which side the point O is on the line 3x plus 5y is equal to 20. It is this side. So if you put the value of x and y to be 0, since the point O is 0, 0 for both x and y, if you put the x and y to be 0 on this inequality, we're going to have 3 in bracket 0 plus 5 in bracket 0 less than or equal to 20. Simplify that, you're going to get 0 is less than or equal to 20. This happens to make mathematical sense, and since it is mathematically sensible, since it's sensible mathematically speaking, we're going to say that the point O is in the wanted region. Okay, and therefore we're going to shade that particular line. We don't want that other side. We want the wanted side, which is the side where we have the point O 0, 0, the origin. We move on to 5x plus 14y is greater than or equal to 35. We set again the point, we use the point O again to test which side we should shade. And so as we do that, we're going to put the value of x and y to be 0 in both this where x and y appears in the inequality. And so we have 5 in bracket 0 plus 14 in bracket 0 greater than or equal to 35, which equals 0 is greater than or equal to 35. This does not make mathematical sense, and that tells us something. The origin side, where we have picked the point O, is the unwanted. Alright, the first case here, it was wanted because it made mathematical sense. The second one, it is unwanted because it is not making mathematical sense. That tells us that this time round, we're going to shade away the origin side. We want the other side, and so there we have it. We move on to x is less than or equal to 5. This tells us that x is numbers like 4, 3, 2, 1, 0, negative, and all that. And therefore, we don't want numbers that are bigger than 5. And so we shade those ones there. This time round, the inequality is just strictly less than. So we have a broken line. You see that? Again, I should say that we don't want values of x that are values of y that are negative. So we need y is greater than 0. So we want that other side according to this inequality. And similarly, we don't want the negative values of x, so we need x greater than 0. And that leaves us with a region, which now gives us a solution of our question. The solution is there's a region that's been left out there, that region there. The question was find all possible solutions. The possible solutions will be the following. We can have that point there, the point 1, 3. Okay? It could also be point 2, 2. Or 3, 2. Those are the only possible solutions. We should take integral values to mean whole number solutions. Therefore, the solutions are 1, 3, 2, 2, or 3, 2, the ones that I've just picked from here, and they are represented there. It means, therefore, this headmaster can only have either one trip of type A and 3 trips of type B, or both of type A and B just having 2 trips, or having 3 trips for type A and 2 trips for type B. Those are the only solutions that the person has within his choice. Those are the only solutions, and not any other. And therefore, that answers the question. All possible solutions, there are those 3 combinations you can choose from. Let's move on to our second and last question for this particular video. We're told that a man has 400 shillings to spend on exercise books and pencils for his children. The cost of pencil is 5 shillings and that of exercise book is 20. He must buy more than 10 exercise books, and the number of pencils should not be more than a third of the number of exercise books bought. So find the possible expenditure on the items. Again, we're going to say let x be the number of books and y be the number of pencils, like we did in the previous case. X is a number of books and y is a number of pencils. Now, the cost of all items. The person only has 4,000 shillings. We are told to spend. He has 4,000 shillings only to spend. That tells us that if we have x times 20, x being the total number of books times the cost per book, plus y times 5, y being the total number of pencils and 5 is the cost per pencil, it should not be more than the amount that he has to spend, which is 400, and therefore it's less than or equal to that, giving us the inequality that you have there, which you can simplify to 4x plus y is less than or equal to 80. And that gives us an equation, this one here. If you set x to be 0, you get y is 80, and if you set x is 20, y will be 0. We move on to another one, the number of books. We've been told that he must buy more than 10 exercise books. So we're told x must be greater than 10, strictly so. And that gives us an equation, x is equal to 10, and obviously that's a vertical line at x is equal to 10. The number of pencils. We've been told the number of pencils should not be more than a third the number of exercise books. So we do it this way. We're going to have y must not be more than, so it should be less than or equal to a third of the total number of books bought, total number of exercise books bought, and there it is, giving us the inequality y is equal to a third x, and if you set x to be 0, y will be 0. If you set x to be 3, y will be 1. So again, this line passes to the origin. I've said let y should be greater than 0 because we assume that he will buy some number of books. We already have x is greater than 10, so we don't need to write x is greater than 10. So y is equal to 0 is the other line that is implied by this inequality, and that is the x-axis. So before us we have the Cartesian plane with the lines drawn. We have 3 lines, x is equal to 10, 4x plus y is equal to 80, y is equal to 0, and y is equal to a third x. Now we're going to shade to find out all possible expenditure for the items. And so the first one, 4x plus y is less than or equal to 80. What does that mean? We're going to look for a point where we want to shade so that we know which side is the wanted side, which one is not. I'm going to pick the point P, 4, 0. This time around, I'm going to pick the origin 0, 0, because there is a line which passes through the origin, and yet I just wanted to use one point, this point here, 4, 0. That's the point I've picked there. I'm going to use that to test all the lines. Alright? Remember, this point should not be, no line should be passing through that point. So as we test, please understand that this line we are testing is this red line here. Okay? So if we put x to be 4 and y to be 0, this particular way, you're going to have 16 is less than or equal to 80. It makes mathematical sense, and therefore the point you picked is in the wanted region. We don't want the other region. There it is. We don't want this other region. We want that one region, which is where we have P, and there it is. We move on to another one. X is greater than 10, and this inequality is strictly greater than. That means it's broken, this line here. All right, and obviously we want values like 12, 16, 14, those numbers that are bigger than 10. Remember, 11 is also a number, or 13, or 15, 17, and all that. So long as the number is bigger than 10. And so we don't want the smaller numbers, and we shade the origin side. Okay, and again, also if you actually test using the point P, you can put x to be 4. 4 is greater than 10. Does that make sense? It doesn't make sense. And so it means point P is the unwanted region. We move on to y is less than or equal to a third x. As we test that again using P, we have x is 4 and y is 0. Putting them on the inequality, you get 0 is less than or equal to a third, in brackets 4. If you simplify that, you get 0 is less than or equal to 4 over 3, which is mathematically sensible, and therefore the point P is in the wanted region as far as this line here is concerned, and therefore we don't want the upper part. We said also y is greater than 0 according to this one here, and therefore we have shaded that. So we have a region that has been left out there which forms our solution, and so the region is this four-sided figure there. Now the question now was what's the possible expenditure on these items. It should be picked such that it is anywhere within the region I've represented with the letter R. And so we have a combination of many points. There are about 12 points, but I've just picked a few of them. This point, this one, that one, all the points that have come on the screen there. And I've also recorded them here. The point 12.2, that means the number of books should be 12 and the number of pencils should be 2, or 14.2 for books and pencils respectively, or 14.4 sorry, or 14.2 or 16.2, 16.4 or 16.2 for 18.4, 18.2 for books and pencils respectively. But I should mention that there are many others. Let me show you, for example, the point 11.1 is possible. The point say 11.3 is also possible. The point 13.1, 13.2, I think 13.3, and even 11.3, 11.2 also. So there are many other points, so long as you are picking integral values. What I mean by integral is there should be whole number solutions for them. All right, and so this gives us the solution for the question, the possible expenditure. These are the ones that I've picked out because of how they came up, because of the sort of scale I used. I used one square represents two units for both x and y axis. So I just got these even numbers, but there are other odd numbers which are possible combinations of the books and the pencils. So expenditure equation, I should say, it's 20x plus 5y, but this is not necessary for us now. We shall look at this in the next subtopic, optimization. So having said that, I must say, check out for the next lesson. Please like, share, and subscribe. Check out for the next video coming or post at the same time with this, which has more questions. Thank you.